Yeah, hi, welcome back. So in this tutorial, we are continuing with the Pandas data frame functionality. So one of the common things that we have to do while doing the data analysis is to read the data from a file into a data frame. So let's say we have a data in a CSV file and we want to read it into a data frame. Then we can do it using pd.read_csv and we can specify the name of the file. Along with that, we can specify other parameters depending upon our requirement. Let's say if you want to skip initial few rows, let's say the data file contains first few rows which don't have actually data. There are some, let's say, junk values in those rows, and we want to skip those rows. Then we can say skip rows equals to that the number of the rows which you want to skip. Let's say if the data is huge and we don't want to read the whole data, we want to read just a sample of records, first few sample records from the data file, then we can specify n rows equals to that number that we want, the number of rows that we want to read. Now another is use columns. So using this we can specify those specific columns that we want to read. So instead of reading data from all the columns, we can read only those columns in which we are interested in doing the analysis. Next is NA underscore values. So quite often the data in the file is missing and and that missing data is represented in a different ways. For example, it could be represented as question mark or underscore or dash. Then all these values we want it to be treated as NA values. So whatever the symbols or whatever characters that we want to be treated as NA, that we can specify using NA underscore values, and we can give the list of all those such characters. If we have any data in a particular column which is of date type, then we can specify that particular column and we can say parse underscore dates, so the values of that particular column are treated as date time. And we can read the data into a data frame and then we can display it. Similarly, if there's a requirement to write the data into a file, let's say we are done with the analysis, we have a data frame and we want to store the final data frame into a file, then we can say data frame dot to underscore CSV. So that is to generate a CSV output of a data frame and name of the file. And we can say index equals to false. So index equals to false means this index that we are seeing here, it will not go into the file. So only the actual data will go into the file. Next is let's say we have a data frame which we have read, and in that data frame, the columns are having uh, some values which we want to replace. Let's say in this case, the first column is A space B, second is C space D, and the third is E space F. Now we want to replace this space between the columns by some character, let's say underscore or dash or ampersand. Then we can rename these columns by using df.columns dot str dot replace function, when we can specify what we want to replace, in this case space with the ampersand. So these columns headers will get replaced, the space in that headers get replaced with ampersand and we get the new column names. Similarly, we can specify to add a prefix or a suffix to all the columns of our data frame by using add underscore prefix or add underscore suffix, and whatever value we specify gets added to these columns. For example, in case of prefix, the company gets added at the start, and in case of suffix, let's say if we are giving value as underscore company, then the underscore company gets added at the end of each of these columns. If we want to display the data frame in such a way, we want to see the end rows first, that is, we want to reverse the order of the rows, we can do it like this: df.log, then colon colon and -1. So -1 means it will start reading the data from the last row and so on. It will go up to the first row and we can display the data. So if you notice in this output, we are seeing 10th of June first, then 9th of June, and then 8th of June, and so on. So it means the data is reversed in terms of the rows. Similarly, we can reverse the order of the columns. Let's say we want to see columns, the last column as the first column, and so on. So we can say like df.loc colon comma and then colon colon -1. So it means this represents the columns. So it means the order of the columns gets reversed So E and F is first displayed, then C and D, and then A and B. So that's how we can reverse the order of the columns also. Let's say we have a data in the form of a data frame just like this. Okay, now this particular data has columns which are of different data types. So to see the data types of each of these columns, we can say players.dtypes. It will display the data type of each of these columns. Now let's say we want to select data on the basis of the data type of the column. Then what we can do is data frame name dot select underscore d types and include equals to the data type we can specify. So all the columns which are of this particular data type, that is number or numeric, they only get displayed in the output. So inverse of this is the exclude. So we can specify exclude equals to number. So it means all those columns which are not numeric display only those columns. So in this case we had only one column player, so only that was now numeric. So that got displayed. Next is to convert string into numbers. Let's say our data frame is this in such a way that there are some missing values, question mark underscore, and so obviously because of these missing values, this particular column and this column will be treated as an object type, not the numeric type. Now, if you see age, it is having all the values as a numeric, but if you notice here that 16 was represented as a string, so this column also will be represented as an object type. Now, if we want to check, we can say df.dtypes. It will display all the columns and their data types. Now, because these are not numeric columns, so we cannot perform any numeric function on these. So, in order to resolve this issue, what we can do is we can convert it into a number. So how do we do this? For example, in case of age, it has all the values which are which can be directly converted into numeric. So we can straight away say df dot as type, and the column is age, and we want to convert it into integer. So data type is integer. So that will convert straight away age into integer type without any issue. But the same logic we cannot apply on these two columns, height underscore centimeter and weight underscore kg. Reason being, these are having these characters like dash or question mark. So what we have to do is we have to find out another way to convert this particular column into a numeric column. So that is we can use another function pd dot to underscore numeric, and we can specify the column that we want to convert into numeric, and then the another parameter that we're passing to this function is errors, so which we are saying errors equals to queries. So wherever we get a value which cannot be converted into a numeric value, that value will be represented as nan. So in this case, height centimeter, so these two are numeric. Okay, now this is a dash, so that gets converted into nan. Similarly, in case of weight underscore kg, if we apply the same logic, so the first value and the last value were having non-numeric value, so those get converted into nan, and rest is the same value that was there in the original column. So in continuation to this, if you want to uh, replace nan with some specific value, let's say 0, then we can use the same code. Let pd dot to underscore numeric and name of the column errors equals to course, and we can append another function that is fill na, and we can specify the value that should replace the nan value. Let's say we want to replace nan values by 0, then we can say dot fill na 0. So wherever there is nan, it gets replaced by 0. Okay, let's say we have a data frame like this. Okay, in which in which we want to apply pd dot to underscore numeric on all the columns of the data frame. Then we can use the apply function. So what we have to do is just df dot apply and name of the function. So this function we want to apply on each of these columns, and we say errors equals to queries. So it means wherever there was a non numeric type of value, that gets converted into nan, and rest of the data remains numeric. To find out the memory usage of a particular data frame, we can use data frame.info, and we say memory underscore usage equals to deep. So it will give you the memory space occupied by the data frame. let's say if we are reading data from a file and our and the file is too huge, such that the data frame that gets created is not able to fit into the memory, then one of the ways we can reduce the size of the data frame is we, instead of reading the whole file in once, we just specify n rows equals to a sample of some number, let's say 100 or 1000. So we instead of reading the whole file, we just read only those particular sample rows. Another method to cut down the size of the data frame is using use calls. So we can specify only those specific columns which we are interested in to perform the analysis, and we read only those columns. So these are the two ways in which we can reduce the size of the data frame while reading the data from a file. Next, let's say we want to apply some filters. Let's say we have a data frame players, and we want to select only those players which belong to Australia and India. So in this case, Australia and India are actually countries which are represented as an index of the data frame players. So, and we have to specify this filter condition on these. So how do we do this? We say players. This is the name of the data frame dot index, because our actual filter is applied on the indexes. So dot index, then dot is in, and the values which we are interested in. So all those players which belong to Australia or India, that is their row index is Australia and India, only those records get selected and are displayed. To inverse this filter logic, we can just simply apply tilde here. What it does, it select all those players which do not belong to Australia and India, and we get the output. Now let's say our requirement is to select those players which belong to top three countries. So how do we find out the top three countries? Now in this case, let's say we have the data from different countries. We have three players from the India, two players from the West Indies, and two players from Australia. So what we have to do, we have to first find out what is the count of the players from each of these countries. So how do we do this? We just specify players, which is the name of the data frame, dot index, because we are specifying the condition on the index on the country, which is actually an index. So we say players dot index, and then the name of the function value underscore counts. So it will do the count of the different categories. So here the categories are different countries. So the count is done. So okay, we got the count. Now from this we want to select the top three, that is n largest, and we specify three. So we get top three values from this, that is first, second, and third. Now from this we are only interested in the indexes, that is name of the country. So we can append dot index, and whatever the output is, we store it in another variable. So this top three underscore countries actually represents the country's name. Now then it's just a simple application of dot isin. So we say players dot index dot isin, and we specified this top three countries that get created here. So the players belonging to these countries only get selected. So that's how we can apply the complex filter logic in this way. We can just break the logic into a couple of steps, and then we can apply it. Missing values. Let's say we have a data frame in which a lot of values are missing, and we want to find out how many values are missing in each of the columns. Uh, the straightaway method to do it is df, which is data frame dot is na, and then just add another function dot sum to it. So it will find out the number of missing values in each of these columns, and it will display it. For example, in case of age, there is no missing value, so the count is 0. For height, there is one missing value, and for weight, there are two missing values. So if you want to find out the percentage of the missing values for each of these columns, you can say df dot is na and dot mean. So in this case of weight, two values, that is 50% of the data is missing. For height in centimeter, one value is missing out of four, that is 25% data is missing. And for age, there is no data missing, so it is 0%. Yeah. Now, often there is a requirement to drop the column if it is having too many missing values. So we can drop a column from a data frame based on some threshold value. If let's say if it is having at least 60% of the data, then we want to retain that particular column. Otherwise, we want to drop that column. So how do we achieve this? We say df.drop_na, and x is equals to columns because we want to drop the columns which do not satisfy this criteria, and threshold is the length of the data frame into dot 60. So it means if the column is for each of the columns, if any column which has at least 60% of data, then that column will be retained. And any column which doesn't have 60% of data, that is it is having 60%, not 60% data, that is 40% data is missing, then that column would be dropped out. So at least, so threshold means this much percentage of data should be there for it to be retained, otherwise it will be dropped. So in this case, weight underscore kg had 50% of missing data, so that column got dropped. Now we can split a data into multiple columns based on some separator. Let's say we have name of the player and we want to split it on the basis of separator, let's say comma. Then how do we do this? Data frame dot name of the column, in this case it is name, then str dot split. We can specify the separator and expand equals to true. So this will create another data frame in which the values get split and they are represented as separate columns. We can just change the name of the columns by giving the specific name. Let's say this is the surname and first name, and storing it back into the original data frame. So in the original data frame, we get the name that was there initially, and these two columns which got created as a part of this str.split function. Now next is we can let's say we have a column in which the data is represented in the form of some list, and we want to create separate columns so that each value of the list gets stored in a separate column. So how do we do this? We just simply have to say df.a is the name of the column, and we want to apply a function which is pd.series. So it will take this value and it will convert it into separate columns. We can apply to this particular code, we can apply another function dot add underscore prefix, and we can specify the prefix value. So these columns are represented now as value 0 and value 1 because the prefix we specified is val underscore. Now whatever result we got, we can concatenate it back to the original data frame by using pd.concat and the original data frame, and rest this particular code is the same what we specified here, and we want to concatenate on the basis of columns. So we say x is equals to column, and in this way we can save this data back to the original data frame. So where we have original column as well as these two new columns which had this particular values. Now we can, if we want, we can drop this particular column A by specifying by using del command. So del data frame name and the name of the column you can say, and it will drop the column. It will drop that column. Okay, thank you for now.